Hello, class. Welcome back. This is lecture 6. Today we are talking about absolute value inequalities. So first off, what is the absolute value? And then, whoops, let's use a more friendly color. The absolute value. So you may have heard this before or seen this before, but let's remind you. The absolute value of a number is, there's many ways to think about it, but this would be the most useful way. The distance from that number to 0. The keyword is distance. Distance is always positive, or it could just be 0. So let's do some examples, and the examples will also show you the notation. So the notation for absolute value is these two vertical lines around the number. So this means the absolute value of 5. And what is it? So then what we do is we write something like this to say what it equals. How far is 5 from 0? Well, it's just 5 away from 0. Since 5 is 5 away from 0. That's the logic. So anytime you have a positive number, the absolute value of a positive number will just be that number because that's how far it is from 0. Absolute value of 37 is 37. Same reasoning for all of these. It's only slightly trickier if you have a negative number. So how far is -3 from 0? It's 3 away. Oops. Since -3 is 3 away from 0, it's just 3 away in the other direction. So we could visualize this. Here's 0. And the absolute value is just saying, how far is this 3 away? It doesn't care that it's to the left or to the right, just that it's 3 away. So a negative number, what's going to keep happening is it's just going to turn into the positive version is the idea. And so this is like a shortcut that people use. They just think, oh, it makes everything positive. But that sort of doesn't help us later. So don't think about it like that too much. We really want to think about it as distance. Okay, and then the last, most tricky one, what's the absolute value of 0? Well, that's just 0 because 0 is 0 away from 0. So that's the last one to think about. Okay, so we're not just going to do absolute values of numbers, though. That would be nice, but we do have to make it a little bit more complicated. So what we're going to do is think about it in another way. So then the absolute value of two numbers subtracted is what we want to think about next. That tells you the distance between the two numbers, or how far away the two numbers are. So let's just see that in action here. So the idea is if I absolute value and I subtract two numbers, that should tell me how far the two numbers are away from each other. So this better be 3, and it is, because 8 and 5 are 3 away from each other. But if I just do it one step at a time, this becomes 3 on the inside, and the absolute value of 3 is 3. So it seems to work in terms of what it's supposed to be doing there when I'm just subtracting two positive numbers from each other. So 5, 6, 7, 8. Yes, those are 3 away from each other, and the absolute value should tell me that. So notice if I switch the order, well, 8 and 5 are 3 away from each other, but so are 5 and 8. They're the same two numbers. So they're still 3 away from each other. Same picture applies. And so our answer better be 3, and it will be. It's just the inner step is going to be -3. And then we say, how far is -3 from 0? It's 3 away. So that's 3. So yeah, it seems to be doing what it wants, what we want it to do, which is tell us the distance between the two numbers. If I throw in some negative numbers, so I do -2 minus 10. So this should tell me how far -2 is from 10, since those are the two things I'm subtracting. Well, let's visualize it first and then see if we get the right answer. So if this is 0, 1, -2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you can go ahead and count, and these would be 12 away. So the distance between -2 and 10 is 12. So is that what this does for us? I believe it does, because -2 minus 10 is -12. And the absolute value of -12 is 12, because -12 is 12 away from 0. Is the long way to say that. And then if I subtract two negative numbers from each other, let's see if it still works. So -4 minus -9, how far away are these two things away from each other? Well, let's see, if this is -4, then this would be -5, -6, -7, -8, -9. And if I just count that out, those are 5 away from each other. Their distance is 5. So this absolute value of subtracting them better be 5, and it will be, because this becomes -4 plus 9, which is 5. And 5 is 5 away from 0, so that is 5. So this is another nice interpretation of the absolute value. If you subtract two numbers and do the absolute value, it tells you how far away they are from each other. So let's keep this distance idea in mind now that we're going to put absolute values into equations and inequalities. Okay, because we're going to use it a lot. So next we put absolute values into equations and inequalities, i.e. we're going to be solving for x, and now there's going to be absolute values involved. So let's just jump into an example. So this would be an equation, because I'm using an equals instead of a less than or a greater than symbol. It's just an equals. So this is an equation that I can solve because it has a missing value that I can look for x. So that's what I'll do. So I'll solve this equation involving absolute values. So how do I solve this thing? Well, let's think about what this is really saying. This is really saying that x is this mystery number that I don't know, but what I do know about it is its distance away from 0 is 4. So this just means that the values of x need to be numbers that are 4 away from 0, because that's by definition what this is saying. This is saying the distance away from 0, that's what this is, distance from 0 of x is 4. So which numbers are 4 away from 0? Well, there's only two. Here's 0, 1, 2, 3, 4. If I count 4 to the right, 1, 2, 3, 4, I count 4 to the left, 4, -4. Those are the only two numbers that are 4 away from 0. So these are the two. Numbers are 4 away from 0. So to solve this, I just say x equals -4 and x equals 4. My two solutions. Because those are the two numbers that if I put them in here, I will get 4. And you can check it. If I plug these in, I do get 4 for both of them. So this is sort of like a check. Okay, so that's one equation we can solve, which is absolute value of x equals a number. So immediately you should be able to recognize, like, how would I solve something like this? Well, it would just be -9 or x equals 9. Those are the two numbers that are 9 away from 0, and there are no other numbers like that. Okay, so then we sort of try to make things a little bit more complicated, a little bit at a time. So let's do that, more complicated. What's next? So what we can do is think about subtracting two numbers like we did before instead of just having an x in there. So we're going to think about things like this. And what does this type of thing mean? So again, we're going to think about the left side as the distance from x to 2. That's what this is really saying. This is really saying the distance from x to 2 is 3. That's what this equation is saying. So if I want to solve it, what I'm really saying is I want to find the values of x whose distance from 2 is 3. So let's think about that. It sort of sounds like a mouthful. Which x values are like this? Which x values are 3 away from 2? So that's how to think about it in words. But let's just write that down in a picture. So 3 away from 2 is what I'm looking for. Here's 2. If I go 3 away, 1, 2, 3, that takes me to 5 in that direction. If I go 3 in the other direction, 1, 2, 3, that would take me to 1, 2, sorry, 1, 0, negative 1. So which x values are 3 away from 2? Just negative 1 or x equals 5. Those are the only two that are 3 away from 2. And in fact, if I plug in x equals negative 1 or x equals 5 into this equation, I can check that it works. You don't have to do this once you're very confident in yourself, but let's see it. So if I plug in negative 1, is this one? Nope, sorry, that was supposed to be a 2, typo. So that would be negative 1 minus 2 is negative 3. Absolute value of 3 is 3. And then is that what I wanted on the right? Yes, it is. I wanted to get 3 and I did. So x equals negative 1 works. X equals 5. Let's just check. And it does also give us 3. So this is good. And in fact, this little check here actually sort of hints at a systematic way to solve these guys very quickly. So let's do that. So we can solve things like this. Very systematically, in a very systematic way, by realizing that what's going on is when I have an equation like this, what I really want is I want to see when does this inside piece equal 3. So I want to set this equal to 3. And that would get me 5. So that's what this is really saying here. Like, when does this equal 3? That will get me 3 as a final answer. So I'll just set that equal to 3, and that will let me solve for 5. But I could also make the entire inside be negative 3, and that will result in 3 as well. So let me set the inside equal to negative 3 too. So that's what we're going to do. The trick is that this gives you actually 2 equations to solve. And solving these will give you the 2 answers every time. And they're just corresponding to this picture of going 3 to the right or 3 to the left. And if I just solve these 2 equations, so I add 2 to that one, I'll get 5. I add 2 to that one, I'll get negative 1. And I'll get the same 2 answers. So this is the systematic method that we'll be doing. So let me do another example using this new method. So if I want to solve something like this, 2x minus 4 equals 6. This really means that all I have to do is solve 2 equations. 2x minus 4 equals 6. So this is saying to go to the right 6. How far is 2x from 4 to the right? I want it to be 6 to the right. And then solve this guy as well, negative 6. And that will give me my 2 solutions. So I just do them separately. So add 4 on this side. divide by 2 to get 5 there. And on this side, this will give me -2, and then I'll divide by 2 to get x equals -1. So, oh, these are the same numbers. Whoops, it didn't have to be the same as last time. Okay, so these are the two answers to this equation. And you could think about it graphically again. It's a bit more confusing because of this 2, but this is really saying which x makes 2x be 6 away from 4. So which x, you want to go 6 to the right, 6 to the left. That gives you 10 and -2. Notice that's what these numbers were right here, not coincidentally. And then you want that distance, you want this amount of to be equal to 2x. So then we're setting that equal to 2x. Okay. So that's just another way to think about it, but we got the method down, so you can just use that nice and safely. All right, let's do one more, slightly more tricky one, where it's much harder to visualize, but our method saves us, so we don't have to. So this is saying, like, I want the distance from 8 to x to be the same as the distance from 4 to 3x. Which x value does that? Luckily, I don't have to try to visualize that. That's a bit tricky to visualize. It just means to solve two equations, 8 minus x equals 4 minus 3x. And this other one, 8 minus x equals the negative version. So I have to negate the whole thing. I have to put the negative around the entire thing, not just the 4, or else it will not work out right. And then we just have two equations to solve. So let's see, I can do this. I can add the 3x to both sides. Give me 8 plus 2x equals 4. 2x equals, and then I'll subtract this 8 over -4, x equals -2. And then the other x value that will work, 8 minus x, I'll distribute this negative through, -4 plus 3x. And then let's see, I'll add this x, add that x. 8 equals -4 plus 4x, add that 4, add that 4. Oops, 12 equals 4x. And so x equals 3 is my other answer. So if I plug those in, they will work. Okay, so this method is nice, and it leads to how things also work for inequalities, which is the last part. So next we throw in inequalities, which you hopefully remember from last time. Now we mix them with absolute values, and it can get a little confusing, but it's pretty systematic. So that's nice. Okay, so we're just going to jump right into an example of what something would look like, and it would be something like this: 2x minus 1. So instead of having an equals and a number over here, we're now going to throw in an inequality. So how about this? So this is saying greater than. And how does this work? Well, let's just try to think about it intuitively first. So this is really saying, like, solve for the x values, making 2x be more than 5 away from 1. Because the left side is saying the distance from 2x to 1 needs to be greater than 5. So I really want 2x to be more than 5 away from 1. And so it can get pretty tricky to try to visualize this, but we can try a little bit. So this is saying I got 1. Here's 1, and I want 2x to be more than 5 away. 2, 3, 4, 5, 6. So this distance here is 5 away. So I want x values that make 2x be further beyond 6. because I want it to be greater than. But I also want x values that are more than 5 away to the other direction. So that would take me to 0, -4. So I want x values that make this distance be beyond -4. But systematically, it's not so rough. What this means is that we need to solve two things again. So we're really solving a compound inequality like last time. So the compound inequality is, well, I can have 2x minus 1 be bigger than 5. So any x values that do that are good. And so those are the x values that make you make 2x be beyond 6 here, which will happen when I add 1 to both sides. We can see that I am yes, solving for x values, which make 2x be beyond 6. So x needs to be beyond 3 for that to happen. But what about this other side? Well, so this is just one part of the answer. And so what we see is we need x to be bigger than 3. And as long as x is to the right of 3, bigger than 3, then when you do 2x, it'll be at least 5 away from 1. And on the left side, things get a bit trickier because it's going to be very symmetric. So it's going to have to do with probably -1 instead of 3, just because of how everything is very symmetric. But I'm going to want to be further that way than -1. So in fact, the other equation that I need to solve, or sorry, the other inequality that I need to solve, so I said it would be a compound inequality, and it is that I need 2x minus 1 to be to the left of -5. And that will get me what I want. So it's an or because either x value will work. So it doesn't, as opposed to an and situation. So x values to the right of 3 will make this one work, will make this happen. And x values to the left of something that we're about to solve will make this one happen. Okay, so we're just going to solve this. So I add 1 to both sides. So I get 2x is less than -4, and x is less than -2. Oh, sorry, I miscounted. This should be, that was not symmetric. -2 is the mystery one. This is my solution to the compound inequality, but how do we write this? Well, remember last time we could use interval notation. And because it's an or, what that means is I just do both. So I say, okay, I can be to the left of -2, not including -2, or, and that means I use this union symbol, I could be to the right of 3 forever. And then graphically, this is saying, here's -2, 1, 0, 1, 2, 3. And I have open circles and I could be this way. And I have an open circle and I can be this way. Any of these x values are good. So that's how I solve something like this. So it's always going to work this way. If you have a greater than, I'm going to emphasize greater turns into an or compound inequality. And we'll see that a less than does not do that. Okay, so let's do that example next. Solve for x minus 3 is less than or equal to 1. So it's not a greater than, so it's going to work a little bit differently. And what this really means is we can think about it in the same way as before, but it sort of gets really complicated. So this really means you want to solve for x values that make 4x be less than 1 away from 3, So you can think about it like that again, but what it's going to come down to is it's going to mean that you want to solve this guy. So you want that. You want x values that make that happen. But you also need the same x values to obey a second inequality. You need them to be bigger than or equal to -1. And so this is how a less than problem will always work out. So less than, does that help? And so this is the compound inequality that it'll turn into. Sort of takes a lot of work to see why this is what you get. So we're just going to jump to it and just use the systematic approach more than trying to worry too much about writing it out like I did before, because it sort of just overcomplicates things. Okay, so we're just going to solve these two. So I'm just going to add 3, divide by 4, and then do the other one, add 3, divide by 4. It's 1/2. So graphically, you want to do graph ones first when you do ands, because then it's easier to do the interval notation. This is saying that I got to be between 1/2 and 1, and I can include both edges. Because I got to be the right of 1/2 and to the left of 1, and as an interval, I can just go from 1/2 to 1, including both sides. Okay, so we'll just do maybe 2 more examples, but using this quick systematic approach. See that it's not so bad. 3 minus 2x is greater than or equal to 4. So greater than, just as a little shortcut, tells us that I got to solve the same thing without the absolute value, or because it's a greater than, or I got to switch it and make the right side negative. That's the trick. And that happens for both or and we're just making the right side be negative and flipping the inequality. So now if I solve this, let's see, I subtract 3 on both sides, divide by -2. Remember, dividing by a negative will flip that guy over. So we got to do that. And then on the other side, -2x is less than or equal to -7, divide by -2, same thing. You got to flip it. The negatives will cancel, and you get that. So I can do this graphically and as an interval. Doesn't matter which order, I guess. Let's do interval first for or. So this is saying that I can be to the left forever of -1/2, and then I can include -1/2, or with the union symbol, I can include 7/2 and then go to the right forever. And then graphically, this is just saying that same thing, -1/2 can be included. So I bubble that in and then go to the left. Then I got to jump all the way to 7/2, bubble it in, and go to the right. Okay, so again, the key is identifying which direction this is facing, because it's a greater than, it's an or. This next example will be a less than. So identifying that it's a less than, that reminds me that it's going to be an and situation. And the 2 things that I'm solving are this one, and then the other one is make the right side be negative and switch the direction. Okay, so 5x is, I just add 1 to both sides, less than 11. X is less than 11 over 5. and add 1 to this one. 5x is greater than -9. X is greater than -9/5. So we get that x needs to be squished between these two numbers. So we got -9/5 on one side, don't include it. We got 11/5 on the other side, don't include it. And any number between them is good. And then as an interval, it's a little bit easier to see that it's from -9/5 to 11/5, and I don't include either side. Okay, so that is it for today's lecture. I will see you next time.